Okay, this question comes from June 2008, Module 4, and it's a gravitational question. Binary star system has two stars, S1 and S2, equal mass m, separated by a distance d. We're first of all asked to write down an expression for the gravitational force between the two stars. So we would normally use F equals gmm over r squared, which then becomes gmm divided by d squared, the separation between them. So Fg then is equal to gm squared over d squared. Next part asks for us to obtain an expression for the centripetal force. So we have F equals mr omega squared. Omega is given by 2 pi over t. So we can say F is equal to m times now the radius of orbit is equal to d over 2 times then 4 pi squared over t squared whenever we put 2 pi over t for omega. So that gives us then that the centripetal force is equal to, the 2 cancels with the 4 to give us 2 pi squared m times d over t squared. And then finally, hence show that the mass m of one of the stars is given by the expression m equals 2 pi squared d cubed over gt squared. And that's because I can now equate Fc with Fg, because the centripetal force is provided by the gravitational force. So we have gm squared over d squared is equal to 2 pi squared md over t squared. We're looking for m, so that m is going to cancel across with that m, and that gives us that m is equal to 2 pi squared d cubed over g times t squared, which if we look up here, 2 pi squared d cubed over gt squared is what we were looking for. And then we're going to use that astronomical observations on a particular binary star system show that stars are separated by 3.6 times 10 to the 11 meters. The orbital period is that, 1.58 times 10 to calculate the mass. Therefore, the mass m is equal to, and we've just worked it out as 2 pi squared d cubed over gt squared. So then let's just fill in the values. So it's 2 pi squared separated by 3.6 times 10 to the 11. That's going to be cubed, divided by 6.67 times 10 to the minus 11 times t then is 1.58 times 10 to the 8 seconds, and so we're going to square that, fill all those values in, and that gives a mass of 5.5 times 10 to the 29. So 5.5 times 10 to the 29 kilograms. And again, a fairly straightforward little calculation there. No problems with, everything's in seconds, meters, nothing untoward there that we need to concern ourselves with. But at the end of the day, we're getting 5.5 times 10 to the 29 kilograms.